if you've gone through your chapter 3 content in your textbook, you got a lot of really good practice on working with if statements and looping structures. If you haven't watched those videos yet for chapter 3 that talk about if statements and looping structures, and you haven't gone through the chapter 3 material yet, you're going to feel lost, and you will be. So remember, this stuff is something that you need to go through. You need to look at those videos on your own, because as we mentioned before, the logic idea of it should just be a repeat of what you've had in your intro to programming. The C# syntax, send me messages in Replit so we can get you through that and get used to it. So let's look at functions. Chapter 4. And like I said, we'll be definitely writing looping and decision-making code as we look at functions. So we'll get lots more practice, or lots of practice to start with. So let's jump right in, because I think once we get to where we can define methods and functions, it makes our code better when we're doing decision-making and looping. We can fit all these pieces together more effectively. So when we're working with C# and we create functions, like a function to calculate a square root, or some other sort of function, like maybe to write a line to the console, all of those functions are called methods. So some programming languages, they call functions subroutines and functions, and subprograms and modules, and all these different names. But what we're talking about here is a chunk of code that performs a logical task that we want to separate out as a module that can be used and called by other modules. So in C#, we call those functions methods. Again, many, many different terms for what a method is. And you could see these in other C# training, where different instructors might call them different names, but it all comes down to a method. C# uses methods, and a method is a logical chunk of code that is defined and can be executed. We use methods to separate functional tasks in the program and to eliminate redundant code. Anytime you see code that seems the same as other code, it's redundant. Why would you have duplicate code in your program? You need to make that into a function or a module or a method that can be easily called. When we use methods, we're using a modular, maintainable programming style. So hopefully you remember this from your intro to programming days, the good old hierarchy chart, where we say we're going to have a main method, and our main method is going to call an input method and a process method and an output method. This is a basic programming structure: input, process, output. So something that we do repeatedly over and over. Whenever we're looking at C#, then our hierarchy chart is identifying the methods that we're going to have in our program. That's Code Matters. Some companies count lines of code and can actually say that this programming group has more lines of code to maintain than some other programming group. Those are people that are looking for something to measure. They don't understand the actual implications of programming and coding, because the truth is less code is better. If I see someone who writes a program and they use, 500 lines of code, and another person can accomplish the same task with 75 lines of code, which code is going to be more maintainable? Which code is going to be something that people would prefer to use on down the road? That's 75 lines of code, right? So back in the day in teaching high school, I saw students who worked with a robotic arm, and the robotic arm would reach out and pick up a block of wood and do things with it. So, they would ask students to do different things depending on what the assignment was. But one common assignment was to pick up a block of wood, and the robot would look to see if there was a hole in the block using sensors and things like that. So good code. If there was a hole in the block would be placed in this pile. If there was not a hole in the block, be placed in this pile. Just like a robotic arm kind of a function they would do in a factory. So what we saw is that students who knew that there were 47 blocks to look at for that robotic arm would duplicate their code 47 times, once for each block. And they would say, pick up a block, check to see if there's a hole in it. If it is, put it in this pile. If there's not a hole, put it in this pile. That little chunk of code, they would just duplicate. Now pick up another block, do the same thing. Now pick up another block, do the same thing. Now pick up another block, do the same thing. That was because they were engineering students and they hadn't been taught to code effectively, right? So students that came in but had a programming background would say, oh, my function is look at the block, see if there's a hole in it to decide what pile to set it in. And I need to do that function every time the robot picks up a new block. And I need to repeat all of this while there are still blocks to pick up, right? And so that's a nice code, nice and compacted code. So if we look at code like that, we would see, again, 35 lines of code versus 200 or 300 lines of code. Their code, where they replicated this 47 times, will not work if there's a 48th block added to the pile, right? Or if one of the blocks is removed. Whereas the efficient code that continues while there are still blocks is going to work no matter how many blocks are added or taken away. If I want to change things and I want to add a third pile of blocks, a third type, I can easily update my function to do that. And I only have to update it in one place because that same function is used for every block. Now, if I had duplicated that code, like those entry-level programmers, I would have had to change it in every single place, right? Every time it was duplicated. So think about that. Less code matters. I want efficient code that is useful and something that can be reused, not code that is super specific and stringy that just keeps duplicating itself. So we want our code to be as simple and straightforward as possible without having redundancy. So what's a method like? You guys are pretty familiar with functions. You should be at this point, but sometimes you can use a little bit more thought process, a little bit more thinking about it. A method is kind of like the chorus to a song. It's that part of the song that you repeat over and over, like you'll hear the verse and then the chorus. The chorus is the function where we just call it every time we want the chorus to sing. Or it could be like a recipe that you use over and over. That recipe is a function. How to make this cookie, how to make this bread. Doing the laundry is kind of the same too. It's a repeated function. You do the same type of processing every time you do it. Whenever we create methods in C#, just kind of like some of our other C# code, it's a little demanding, right? It's a little picky. It's not as easygoing as Python or some other programming languages. It's like, no, you have to do it exactly right the way I want it. Well, declaring a function or a method in C# is that way too. Whenever we declare a method, which we've done over and over with our main method, remember we've used it repeatedly so far. Whenever we see that line of code that defines that method, that's our method header. Inside the method then, we have the method body, and our final closing curly brace is the closing of our method. Our method header includes the opening curly brace. So a method has an opening and closing curly brace to keep it in Check. Here's one. This method header is kind of long. It's a little bit more involved than what we've seen so far. This method is called my method. It has some special modifiers at the beginning. Oh, he did come in late. Sorry about that. I haven't marked abs and I didn't even realize he sneaked in. Thank you so much. He's going to be taken off. Bye, have fun. For careers, letters, stuff. Oops. Okay, so the first thing that I'm going to have in my method header may be some modifiers. This method header has modifiers that say public and static. We'll be learning what each of those modifiers do. Just be aware that we could have them at the beginning. The next thing, where we have the word void in this one, is the return type. Any data that's going to be sent back by my function has to have a return type. This function, my method, doesn't return any data. She's going to let you reschedule with those other guys?
No, it was going to be the senior thing, so that like I go through the OTC, but I am already going to MSU. So.
Oh, so you're set. Okay. You get to stay then.
Yeah. Thank goodness.
That's what I was just trying to figure out. Are they going to make you go or are you going to stay? So right here in the middle where I have my method is actually the name of our method. And I remember when I first saw method headers in C#, it kind of made my head swim. It's like, what in the world is all this stuff? So we'll be identifying each little piece as we go so that it all starts making meaningful sense to you. Everything within these parentheses is called the parameter list. Then at the end of the method header, I have my opening curly brace. This statement here will declare a method named my method. The method expects a double value as a parameter to be passed to it and returns no value because it's void. So we've used one method a lot, a C# method that exists called Writeline, right? That's the method we've used most so far in our class, I think, where we've output data. So when we create a method, it's like we're creating our own version of that Writeline method. So here is that same method header that we saw earlier. It's just that now I've put it in this same 3-color block. My opening curly brace and all of the method body is the code inside my curly braces, and then I have my closing curly brace. So here's a good one. Let's write this one. We'll do it together in Replit. We've got a little main, and it calls a method called my method. Let's open our Replit real quick. See if I can find one. Let me get you marked here too.